Now question says 2 into 2 raised to the power 2x minus 5 into 2 raised to power x plus 2 is equals to 0. Question says find x. It is always easy to handle when we use substitution. So I say let y be equal to, I'm observing these terms, 2 raised to power x and 2 raised to power 2x. So I can replace them and write y is equals to 2 raised to the power x. So basically this is now 2 raised to power x and 2 goes outside, minus 2 into 2 raised to power x plus 2 and 2 raised to power, this is 2 raised to power x is y, which makes it y square minus 5y plus 2 is equals to 0. Now we can go for midterm breaking. 2y square plus 2 and midterm is minus 4y minus y. So we're taking out common 2y, y minus 2, minus 1, y minus 2. 2y minus 1 into y minus 2 is equals to 0. So first factor equals to 0, second factor equals to 0. We keep on simplifying and I get 2y equals 1, y equals 1 by 2, y is equals to 2. And we knew that y is equal to 2 raised to power x. So for 2 raised to the power x is equals to 1 by 2 and 2 raised to power x equals 2. So I can write this as 2 raised to power x is equal to 2 raised to power minus 1. On the other side, which is already clear, it is 2 raised to power 1. Therefore, x is equals to minus 1 and positive 1. Another question by substitution and use of log. It says 3 raised to the power 2x plus 1 minus 26 into 3 raised to the power x minus 9 is equals to 0. And it says solve for x. We can now again use 3 raised to the power x is equal to y. So I'm splitting this up. This is 3 raised to power 2x into 3 raised to power 1. Indices, basis same, powers add. Minus 26, 3 raised to power x minus 9 is equal to 0. Now 3 raised to power 2x could be written as y square. So this is 3 y square minus 26 y minus 9 is equals to 0. After getting quadratic form, we go for midterm breaking. 3y square minus 27y minus y minus 9, this should be plus y is equals to 0. So we take out common, 3y left with y minus 9. On the other side plus 1, y minus 9. So 3y plus 1 and y minus 9 is equals to 0. First factor equal to 0, second factor equal to 0. So y is equals to negative 1 and negative 1 by 3. And this is y is equals to 9. Now we knew that y was equal to 3 raised to power x. So 3 raised to power x is equals to negative 1 by 3 and 3 raised to power x is equals to 9. And on left hand side we know that this is rejected. 3 raised to power anything cannot be a negative number. If we go for the next step, if we apply log, this would be x is equals to log of negative 1 by 3 to base 3, and we just discussed that log a to base b, both of these cannot be negative. This has to be positive and positive, and because of this negative, this is rejected. On the other side, Either we write 3 raised power x is equals to 3 raised power 2 and say x is equal to 2, or we apply logarithmic method, which is x is equals to log 9 to base 3, use of calculator, or still, because this is a perfect square, x goes as log of 3 to base 3 and 2. So we do it either way, we get x is equals to 2. So if we are asked to sketch a graph, draw a linear line applying logarithms. So if we have a question like y is equals to pq raised to power x, I can apply log on both sides. This would be log of y is equals to log of pq power x. Now I am using the multiplication law, that is log of y is equals to, once they are multiplied, I can split them with a positive sign, log of q power x. Now I'm using power law. Log of y stays there. This is log of p plus x log of q. Now we know we had a generic term y is equals to mx plus c. So allow me to rearrange. I'm writing it as log of y and bringing this term first is x log of q plus log of p. Now to compare, if I write y is equals to mx plus c, so by comparison I know that this is y, that would be on the y-axis, so log y, and whatever is with the x is the gradient, so x would be on x-axis and my gradient is log of q. So either I use this line to find the gradient and equate it with log of q to find value of q, and this intersection part would exactly be equal to log of p. This is c, this is log of p. C is equals to log of p. So that is basically linear law. Okay, so let's try some questions.